So welcome to our talk. We want to present something we have worked on for a couple of weeks now, basically conference-driven development, as everybody loves it. And it started out in August, and I realized something which was kind of embarrassing because I was in the middle of this construction team there which built the bridge. In Kubernetes, we do not really support software as a service. So my usual example is, I have a kube cluster and I need a MySQL database. How can I declare a MySQL database 8 years into Kubernetes? It was hard at the time before CRDs were a thing, but even today it's hard. Like you can find a MySQL operator and install that somehow with Helm and hope it works. You cannot easily get a MySQL database declaratively in Kubernetes from any cloud provider. So if I want to have an RDS from Amazon, for example, it exists. I can click through the Amazon API and create an RDS instance and somehow get a service into my cluster. But this is all complicated. And the question was, can we make that simpler, much easier, and support SaaS in a native way? So this is a rant. It's a Twitter thread from August. So no SaaS, lots of discussion around that. There's ACK and similar things for Azure. So there are operator kits which put cloud APIs into Kube. They exist, but my claim here in the talk is we shouldn't build those things. We should have something better. And yeah, basically the rant is 6 years building operators. Everybody is involved in those operators. They are complex, right? It's 1,000 lines of code, of Go code, for simple things like offering and CRD for cloud API. So 6 years of building operators and maybe not the best use of time. And installing operators is one thing. Helm install an operator. Every time I do that, I ask myself, is this maintained? Does it work in a year? And I really don't want to maintain this thing. So I have to upgrade maybe once in a while. So I built something around maybe GitOps base to update Helm charts. And we are building this. We as an ecosystem basically build something. A SaaS API should be native without all the glue around, without thousands, tens of thousands of Go code, building operators and running them in my cluster to get a MySQL database. And as a disclaimer here, I'm not talking about operators in the real sense of operating. Like when CoreOS announced the etcd operator, the first one, and Prometheus, I think. This was about operating, like running etcd instances, which is complicated as everybody knows, to run them in the cluster. And this is totally valid. That's a valid use case for operators. But we are building operators for not running stuff in the cluster, but to consuming stuff. And this is basically what we get. So the result of this thread in Twitter, and then we gave a talk in Hamburg at the Container Days about that. We want to build something which makes consumption of services Kube native. And the result of that is, if we build such a thing, and it's about Kube APIs, which we get into the cluster for those services, we have basically a service provider persona in the story. And this is mostly missing in Kubernetes nowadays. We don't have that. Like there is this admin of a cluster, as the owner of the cluster, and there's a user of a cluster who's not admin. This exists, but there's no service provider. Maybe the developers of operators, they are something like a persona for service providers. So everything should be secure, of course, and Kube native, of course. So here's the future. This comes from the talk from September, I think. Yeah, I think we'll just give it 2 moments.
So hi everyone. So as what Stefan already mentioned, things should be way simpler, and you as a user should be only, care about how things should look like from a user perspective. We have been using kubectl for quite some time now, and what we should do is, for example, kubectl bind, and then you bind into a URL. And that thing will just hypothetically start the browser for you in order to authenticate and authorize. So you choose, for example, to go with GitHub, and then it asks you, of course, about some information, the same OIDC style that everybody see and know. And afterwards, you get what really matters here. You are interested of getting this service that's called MongoDB, for example, up and running. We give you, or the service provider persona in a way, gives you the information that it only cares about, which is, or the user that cares about, what kind of tier you're running in, the region, backup, and some other, of course, other stuff that you as a user and as a consumer would care about. Then you bind into this API or into this service, and afterwards, for example, the service provider, of course, needs some assets that needs to be installed in your cluster, such as secret or whatever that the service provider needs in order to complete the service that they are providing. Then you as a user, for example, you would just accept these claims and you have the transparency. You know exactly what the service provider is installing in your cluster. It's not just you go into an operator, you install whatever CRDs, whatever services, whatever Kubernetes objects in there. No, you actually vigilant. And the high level of transparency would be reflected here. And then what happens? That's it. You actually got the CRDs, got the things that would get your application or your service up and running, and it's there. What is really important is, if we take a look at the claim or the binding that we did, those are the things that we saw in the browser. That's what matters to us the most as a service operator, as a person who would like to use that. And yeah, off you go. That MongoDB instance or CR is there. Now, what's super important is the pods. Some would say, if I create this CRD, I might be seeing something, a pod, an operator, something that runs in my cluster that decides how my service looks like. No, nothing. You only see the API server, the control plane, the things that everybody knows about Kubernetes, the normal ones. Nothing there, no operator, no shenanigans, no magic, just what do you know? And you control that. Let's take a look about the CR. Here it is. We have a MongoDB that runs somewhere. We know it's running, hence the phase over there. So it gives you also the size, it gives you the region, and all the information that you already saw before and you approved. And then if we take a look how this thing looks like, CR. It's a custom resource or custom resource definition that you vigilantly approve to use. And it has all what it matters for you. And if we take a look at the service, for example, you get a service that you already saw and you already approved. And then you get something very interesting, which is the bindings. The bindings decide what you have actually bound to, what is the face for it. We bound into this MongoDB resource, and it gives you all the informations about it, when you did it, some phase, and some extra information that maybe the service provider get to decide. That's it. You have it. I give it back to Stefan. Oh, sorry, you have one.
So, just to stress the points again, so there's nothing running in this cluster where we bound to. So it's a service which is provided by somebody else, a SaaS, basically a software as a service, but Kubernetes native. And this was basically, it was a rant in Twitter, and we talked about, this could be done probably. We showed this demonstration, and let's build this thing. There's KubeCon coming, and we have built it. So that's KubeBind. KubeBind is a project. It's open, so you can go to GitHub and check it out, try it out, contribute, of course. It's vendor neutral. That's important. There is something running on a consumer cluster. We call it a connector. A connector, which is a small agent which maintains the CRDs. So you saw a CRD installed. So very important. This is not about an installer. It's not an installer what we have built here. It's something, it's a binding which has persistence, so it lives on. This cluster we have seen there, it's still bound to this API. When the service provider updates the CRD, this agent will pull it down, the updates, and update your CRD. If the service provider needs a different claim, he will tell you, like accepting something like creating another secret or something. So this thing is living. It's a long-term connection between a cluster and a service provider. That's binding. That's what we call binding. And KubeBind implements that, and you see here at the bottom, so basically it's a kubectl plugin So you can use krew, so you have to install krew first, and you have to add the index because we are not in the public index yet. And you say just krew install bind, and then you can say kubectl bind. It's here, kubebind. We have a Slack channel for discussion. It's open, vendor neutral. We love collaboration, so if you're interested in that, please join. It basically implements those two things. And I had a chat earlier today already about this topic. There is the bind command. We have seen that already in the first part of the presentation. You bind to a URL. The URL implements some protocol for binding. It's a binding provider. And eventually, you get the CRD. But actually, what is happening, there are two parts. There is this whole authentication flow, like the web UI thing where you can click around, you authenticate, you click on the resources you want, maybe other stuff, so depending on the service provider. All of that is totally open. So it's not set in stone. You can customize that. What we have here is an example implementation. So we will see that in a second, where you can select the CRD from the service provider. But everything on the authentication part and the web UI part is totally up to the service provider. After the screen command, what comes back is basically an API service binding request. It's a generic, or it's an object which defines, which declares what to bind. You can pipe it into a file, for example. And then there's a second part, which you can also manually execute. So you can use it for automation, for example. So you can put something like that into your Argo CD or something like that. So the UI part is really the development story. It's super nice to just be able to click through some UI and find the right resources and be done. A few clicks, super easy, nothing to look up, nothing to remember. Of course, in some automation setup where you want to do it automatically, you also need something. And that's basically the second part here about kubectl bind API service, then the request and some remote kube config to get to the service provider, and then you are done. So you get the CRD and everything as we have seen before. So this you will find when you go to the repository. So there's a kubectl bind command. There is a connector, which is the agent. So the kubectl bind will automatically install that and maintain that and update it. The connector is running. The connector is basically pulling CRDs. And it's making sure the objects you create, like you create a MongoDB object locally, this is sent to the service provider. So there's a syncing process happening. It's sent to the service provider, and when there's an update of the status at the service provider side, this is synced back into the consumer cluster. So it's both ways, syncing up the objects and the spec, syncing down the status, basically. And the other thing, what is also in the repository, is this example backend. But as I said, it implements a protocol. It has some example UI. It has integration with OIDC, so you can connect to GitHub or something like that for authentication. But it's really just an example. The protocols matter. Everything else can be customized and should be customized. That's a bigger picture how this example plugin works. So on the left side, this black terminal session here, that's the consumer cluster we have seen previously. The connector as the agent, the kubectl bind operated by the user. On the right side, you see the service provider. The example backend, it's running on a kube cluster, on any kube cluster, basically. You can use an OpenShift or Kubernetes, GKE cluster, whatever you like, run the example backend, and it will implement those APIs, the protocol we have defined for binding. Kubernetes has namespaces for isolation. It's not great. It's, of course, isolation you can expect from namespaces, but you can turn a Kubernetes cluster into a service provider that way. And very important, you can use a standard operator. You can use, so I played with the MongoDB operator and just implemented that. So the MongoDB API implemented at the back end via an open source operator from the community. This works. I will show it. So on Thursday, I have a longer talk about that. I will show that as a demo, how you can do that with crossplane in between. So it's pretty nice. You get a MongoDB without any line of code. You can become a MongoDB service operator without writing code, which is pretty awesome. Yeah, the isolation, as I said, it's okay-ish. Every cluster gets a namespace, a cluster namespace. So if you have many clusters here, for each you have a namespace at the end. And if you create a namespace here with a MongoDB object, so in the example, we were in the default namespace, so we created the MongoDB on the left side, then a corresponding namespace is created on the other side, on the right side, of course, with some prefixing to make it unique. But all of that, again, this is not a protocol which matters. This is an example implementation. So if you want a different implementation, bigger scale, many clusters, totally possible. What really matters in kubebind is the protocol. So if you go bigger and you want to have really thousands of clusters connected, like a real software as a service, imagine MongoDB or any other database as a service company wants to use that. They need smallish Kubernetes like workspaces. So KCP has workspaces, which are like kube clusters, but they are much, much cheaper, much smaller in memory consumption and CPU consumption, but they give much higher isolation. So if you want that, KCP is a natural backend if you want to really scale that up. But if you are in an environment like you as an IT service provider, for other teams, like you provide databases, MongoDB databases for your development teams, maybe you don't care about that. It's totally fine if you have namespace isolation. All right, so just the real thing. Colleague of us, Sergius, played with CockroachDB. Again, it's a random operator for a database taken from the community. And let's quickly...
That actually works.
Which actually works. And this is also background for all, or the motivation for all of that. I'm not sure about the experience with operators by you. My experience is often not so good. Quality of operators, they often don't work, and you really have to have lots of knowledge to understand why. That's why we want this, the separation of personas. So here you see basically this UI, very simple. There's a CRDB cluster, CRD, coming from this operator. You can bind to it. It happened. One command, CRD exists. And you can create a CockroachDB object, which Sergius will do in a second. So there's none. On the right side, at the bottom, that's the provider cluster, the service provider cluster where the backend is running. So the upper part is the consumer cluster. So here is an example, CockroachDB. Everything here is real. It's not a fake as in the previous part of the presentation. So let's apply the example. It's there. At the bottom, you see something happening here. So there was a namespace created. And the operator in the background is doing something. So you can see here, there's the instances of Cockroach. The pods, I think he's showing, right? Yeah, he does. So pods are created, totally invisible from the consumer. Consumer does not see anything of that. And if you go back and you check the CR, you will see there is status, like conditions, everything is synced down. And again, the pitch is install this plugin, call kubectl bind against a URL of a service provider. Enter, click through some UI, bind, done. All right. Does it end with API services? So I'm from the API side, so I've been involved in CRDs so much. I love APIs. That's why I built that. But binding, of course, is a much more generic concept. So not coincidentally, the command is built, or basically spec'd in this way. kubectl bind is generic, then there's API service. So think about, there can be other things. Again, a binding is something which is like an installer, but it has a life cycle. Like the things are bound to this cluster and updated by the service provider. Think about examples which might be similar. Network connections, so any kind of service binding. There have been work about service binding operator. People will know that. It could also be something like that. Totally integrated into kubectl bind. kubectl bind will do all the flow at the top about authentication. Eventually, it will call the kubectl bind and then the type as a subcommand. So you can provide another subcommand, follow the protocol in the beginning, and then provide the subcommand to do the actual binding. So you could bind something like a network service. There were also ideas about something like an agent service. So some service providers like, I don't know, profiling as a service built by Polar Signal, for example. They need an agent to send profiles to their service. This is also a binding, right? You install something into the cluster, it sends the data to the service provider. Could also be built in this way. So be creative. There are many more kinds of bindings that would or could make sense. All right, there's more, so we only have 25 minutes now. There's another talk on Thursday, and we have a room on Friday 11 where we can just go into more details, discuss, get feedback, think where this could go. It's an open source project, you have seen. We have built the basis, but we want to see where this could go. So if you are interested in that, you're a service provider, or you're just interested on the consumer side in the experience, talk to us. There are those 2 locations where you can do that. All right, so there's, if you want to re-watch that or share it, we shared the first part of the talk here at this address, kubectl.io. Kubebind at the Slack of Kube, so you can just join us there in the channel. There's a repository. We love collaborations. This is not something by one service provider. It should be a generic thing. If this is interesting for users, like binding in one command and a few clicks, this could be the basis. All right, and this is what you are finding in the repository again. So if you want to play with that, it's there, documented in the README. Everything's alpha here, so it's pretty fresh and new. So don't expect that everything works. It's not production ready for sure. But it's much more than just a prototype. The basis is there. All right. So far, that's the presentation part. And if there are questions, they're at the back.
Love this. I think it's a great space. I'm curious to know whether you think that a project like Service Catalog, which sounds very similar to this, did not get a whole lot of adoption. If you think that was just premature, now the time's right, why do you think this one might be more successful in Service Catalog? Is that always disappointed about?
Yeah. So one thing which the UX should be super simple. And it should be possible for the user of a cluster who can just call the command and get a service. He doesn't have to ask anybody. That's basically the core idea here. So the users can use the technology if they like it. We don't need an aggregated API server, something which is really complex. And Service Catalog did that, right? It was really deep in the system. It was awkward to operate. And you had to convince your admins in the company, for example, to install that. So it was pretty complex. There's one more thing. Everybody knows companies who are wrapping cloud APIs today. There are some companies, some startups, or part of the business basically is to take cloud APIs and build Kube APIs out of that. They can offer that, right? So even if the service provider like MongoDB is not interested in that, somebody else can do that. The tools are there and can offer the service. Even internally in a company, your IT department, the database department, they can use this tool to offer a service. So the user is pretty free to consume, and the service providers, if they opt in, they use this thing and implement it, it's cool, but there's a second approach where some other party does the wrapping, or even that works. So the barrier, I think, is lower than in Service Catalog. It's much more federated, let's say. Mo, I think you are first.
So I'm trying to mentally map my RBAC model to this. If I need CRDs on the front end, exactly how would a normal user run this command?
Yes, for CRDs, you need that, for sure. So you must be admin in this sense. So we don't solve the CRD problem, not with that.
How does the authentication
Yes.
myself as some root user on the cluster?
So the authentication you have seen is against the service provider side. It's not about the local cluster. It's not using the whole system, like the service provider is not, or your cluster is not protected via airbag. So you don't depend on airbags that the service provider cannot do bad things. We don't do that. Like the agent is the trick here. The agent, which is open source, and it follows a protocol, this implements the things we have seen at the very beginning. You remember when Mode said yes, there was this prompt, yes or no. Basically, you told the agent, the connector, to implement this protocol, which includes that only the things which the user opted in are really done, right? It's a pull model. It's coming from the consumer cluster, talking to the service provider. That's why it's safe without any additional airbag power, because airbag is not powerful enough for that. That's also, of course, important.
The specific problem I'm speaking of is not that one.
Mm-hmm.
More of, so I have a cluster admin.
Mm-hmm.
I detail bind it to some MongoDB thing.
Mm-hmm.
Now I have these CRDs available on my cluster.
Mm-hmm.
And I authenticate it as some OIDC identity,
Mm-hmm.
something, GitHub, whatever.
Mm-hmm.
And I federate that identity out. And then I'm going to give my regular developers the ability to use MongoDB, presumably on this cluster. How is my original credential that was basically used to attach my identity to some MongoDB?
That's a story about how you can give an API like this community operator thing, or maybe Mongo Atlas is their SaaS offering, how you give that in a secure way to engineers. In this demo with crossplane and stuff, in the bigger talk, I think you will see something which is an answer here. Basically, it's about hiding the actual API which has the power of your credentials and turning that into something simple and secure and controlled for your use case.
And just to add one thing, I mean, don't forget the thing that you saw on the consumer cluster. So potentially you're the admin cluster and you got this MongoDB CR, right? You could hypothetically create some service account, give it some information. Like you cannot update this MongoDB CR, and you can forward that service account to your colleague or to different people. So you can decide, for example, how others can communicate on resources on your cluster based on normal RBAC from Kubernetes itself, right? You can say that I create this, I bind into the MongoDB thingy, I am the admin, now I would like others to use this CR on my cluster. I just create a CA for it, you're allowed to get, you're allowed to update maybe something, but not delete, for example. So you decide how people would interact with that by the end of the day. The important thing is once it's bound, it's there, then it's up to you how you distribute it.
And it also means, maybe that's confusing because the example is too simple. Like you authenticate as Mo in GitHub, right? Doesn't mean that at the end the CRD, which is important, basically operates under you. The service provider can provide something like a service account for this cluster, and there can be quota assigned and everything. So it's just simple here in this demo that you go to GitHub and it's running under your account. It can be something else, of course. All right, James? Yeah, we haven't settled the details here, I guess. Yeah, probably. I mean, if the permission claim is to get access, it would be synced up, yes. If the permission claim needs less power, whatever this means for a secret, I'm not sure what it can mean. We can talk about that. Those permission claims, it's a sketch at the moment, so we have to talk about which makes sense, which are secure. Those should be minimal, of course. This should be, I mean, that's the rule of thumb, right? Right.
As I understand it, connector is a client here, right? We're not allowing the backend.
Yes. So there's no access to the local cluster. Very important. And no aggregation or anything like that. It's really a pull model.
And related, I think, to James' question is when you bind, it didn't ask you anything like, are there a subset of namespaces to which, for instance, can it read all the secrets in the cluster?
So, yeah, I mean, this is again this permission claim thing. We have to design that, the details about that. Restriction to a name and the namespace makes sense. Like in the example, I think we only had a name, not a namespace or something. That's what you're meaning, right? Yeah, it's too simplified. That's a demo. It must be, again, minimal. So we have to provide everything which is necessary to make it minimal. The power a service provider needs to express the need, but in a minimal sense, yes. All right, so if there are no further questions, you have seen the repository. You saw the two chances to talk to us. So we have this talk on Thursday at 11, I think, and Friday, that's open floor, I guess, a room with 50 people, I heard. So if you have more questions, you want to talk about API and stuff, that's a place. So please join us. Thank you.
Thank you.